Find the total area of each rectangle below. Each number inside the rectangle represents the area of that smaller section, while each number along the side represents the length of that part of the side. So 12 is the area of this rectangle, 39 is the area of that smaller rectangle, and so on. So we know that this one, 11 times 4, the area here would be 44. We know that this side's going to be 4 and that side's going to be 11 since it's a rectangle. It carries over. So I need 4 times something equals 12. So that means that side has to be 3. That means that this is 3. If this is 3, 3 times something is 39. So that means this part has to be 13. And then that means this is 13. So then 13 times 11 is 143. So then the total area of this rectangle is 12 plus 39 plus 44 plus 143, which is 238 units squared. We could check that by multiplying the whole side. So that's 3 and 11 makes 14. 4 and 13 makes 17. 14 times 17 is 238. So if we did the whole thing, 14 times 17, we'd also get 238. All right, on this one we have 8 times something equals 40. That's going to be 5. So that's 5. 6 times 5 is 30. Let's see, we know that's 6. 6 times 3 is 18. 3 times 8 is 24. So then the total area, 24 plus 18 plus 40 plus 30, is 112 units squared. We can double check that. 3 plus 5 is 8. 18 plus 16 is 14. Or 8 plus 6 is 14. 8 times 14 is 112. So we're good. Solve each equation below for x. So here we've got x divided by 8. So I'm going to multiply both sides times 8. And I get x equals 3 times 8 is 24. 24 divided by 4 is 6. Here I'll multiply both sides times 40. 2 times 40 is 80 divided by 5. 80 divided by 5 is 16. Here I'll multiply both sides times 12. 12's cancel. I get 12 times 1 is 12 divided by 8. Here we can simplify this dividing by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. On this one I'll multiply both sides times 10 to make my 10's cancel. So I get x equals 10 times 12 is 120 over 15. I know that we can simplify that by 5. 120 divided by 5 is 24. 15 divided by 5 is 3. 24 divided by 3 is 8. What is the equation of the line that has a y-intercept of -3 and passes through the point -9, -9? If you need to, draw a sketch of the line in order to solve the problem. So I'm going to do that. Has a y-intercept of 0, -3, so that's right here. And passes through -9, -9. That's down here somewhere. So I know that my line looks like this. So I need to draw a slope triangle. I know that I went from -9 to -3, so that went up by 6. And I went over from -9 to 0, so I went over 9. So my slope is the change in y, so 6 over 9, which just simplifies down to 2/3. And I know that my y-intercept already is 0, -3. So the equation of my line is going to be y equals 2/3 x minus 3. Find the domain and range of the following graph. So the domain is the x values. So I start here at x equals -4. And I see that it's a closed circle, so I'm going to be less than or equal to x. And it looks like here that this graph goes on forever. So we're going to say that it's less than infinity because it keeps going this way forever. The range, the lowest point on this graph is y equals 1. And I also see here that it goes up forever, so we say it's less than infinity. Harry the hungry hippo is munching on the lily pads in his pond. When he arrived at the pond, there were 20 lily pads, but he is eating 4 lily pads an hour. Heinrich, the hungrier hippo, found a better pond with 29 lily pads, so he eats 7 lily pads every hour. If Harry and Heinrich start eating at the same time, when will their ponds have the same number of lily pads? How many lily pads will be left in each pond at that time? So we're going to create a table and a graph to solve this problem. So Harry, at 0 hours, Harry had 20 lily pads in his pond. At 0 hours, Heinrich had 29. Harry eats 4 lily pads every hour. So that at hour 1 he'll have 16, and then he'll have 12, and then 8, and then 4, and then 0. Heinrich eats 7 lily pads every hour. So he'll have 29, and then 22, and then 15, and then 8, and then 1. And then 0. So I see that at hour 3, they have the same number of lily pads, which is 8. So at hour 3, each pond will have 8 lily pads. And we can graph that information because our independent variable is time. So this is number of hours. Our dependent variable is number of lily pads. And then, let's see, we need to go up to 5 hours, so I'm going to skip by 4s. 1, 2, 3, 4. That's 1. 1, 2, 3, 4. 2, 3, 5. This is 0. Our lily pads need to go up to 30. I think we can skip by 1. So 1, 2, 3, 4, 5, 3, 4, 10. 1, 2, 3, 15. 1, 2, 3, 4. So we've got Harry, who starts at 20 and goes down by 4 every time. So he's at 16, and then at hour 2 he's at 12. At hour 3 he's at 8. At hour 4, he's at 4, and then he's at 0. So this is Harry. And then Heinrich starts at 29, 26, 27, 28, 29. And he goes down by 7. So at 1 hour, he's at 22. 2 hours, 15. 3 hours, 8. 4 hours, 1. And this is Heinrich. I'm going to color his in yellow. My yellow doesn't really work. So we see right here their intersection. And so their intersection is 3 hours and 8 lily pads.